Bismillahirrahmanirrahim. Time dilation explained. Special relativity with examples. So, in this video, we are going to explain the time dilation. So, let's start. Time dilation is a prediction of Einstein theory of relativity. Moving clock runs slower compared to stationary clocks. When a clock is moving with velocity v, it slows down. This effect becomes significant near the speed of light when it is nearly to this. If the object is nearly moving with the speed of light, the clock of that object slow down significantly. Okay, formula for time dilation. So this is the formula for time dilation. The t naught is proper time, that is the time read by the object which is moving with velocity v, and c is the speed of light. So let me write it again. T is recorded the time of the moving object. No, t naught is the time, proper time, and this is recorded by the object. V square over c square under root. So that is the time dilation of the object. This is, in fact, we can say it is actual time. This is the actual time, and this t is the time dilated time. Time passed differently per observer in relative motion. Time depend on the velocity. If the velocity is larger, then the time dilation feel. For a small velocities, the time dilation is very small and negligible. Higher velocity lead to greater time dilation, and low velocity leads to small time dilation. At speed close to light, the effect become dramatic. Okay, example, spaceship move with the velocity. So this is example. Let's understand what the time dilation means. So a spaceship moving with this velocity, 0.8 time the velocity of light. Proper time inside the ship is 1. That is the time inside the ship. So the people feel 1 hour. Let's say 1 hour movie. Find the time measure on earth. So the time on earth should be t is equal to t naught over 1 minus v square over c square. So let's put the value. The proper time is 1, that is recorded inside the ship, but what we record for them, that is 1 minus 0.8 c over c whole square under root. So this t is equal to 1 over 1 minus cc will cancel, that is 0.64 under root, and this is equal to 1 over 0.36 under root, and this is t is equal to 1 over 0.6, and this give me 1.67 r. So it is more than half an hour on Earth. This calculation is given over here. You see, this time is recorded on the Earth, while the time pass in the ship is only 1 hour, and it is more than half an hour. So that is the time dilation. The time dilation occur for the moving ship. Okay, one twin travel at relativistic speed. The travel twin age more slowly. After returning, the travel is younger. So let's say it is in the previous example. Let that 1 hour is 10 years. So that 10 years time pass in the ship, 10, and we see that it is divided over 6 in the previous slide. So 10 year pass in the ship. So we have two twins of the same age. This one is in the ship, and it passed 10 years in the ship. This ship is moving with the velocity v is equal to 0.8 c. So it goes away, and 10 years after it come back. So its age is 10 years. So what is the age of the other twin on the Earth is this. This is 10 multiplied by 10 divided by 6. That is 100 divided by 6. So t is equal to 1 and 6.67. So about more than 16 years pass on the Earth. So that is the time dilation for the man in the ship. The ship, this man has age 10, while on the Earth 16 years pass. So that is the difference, and that is the time dilation occurs. So when a man moving with velocity v, the age of that person passing slowly. You see in this example, the age of the man on the Earth is 16.6 years, while the age of the man inside the ship, which is moving with this velocity, is 10 years. So that difference occur because of this high speed of the ship. So when a body moves with velocity v, time slow down for that body. Okay, so let there is an experimental verification for this phenomena. Muon decay experiments confirm this dilation. Muon with a lifetime. So muon are particles that produce in the Earth atmospheric about this much above the Earth's surface, 10 to 15 kilometer above the Earth's surface. Its lifetime is this 2.2 10 power minus 6 seconds. So it is created, here is the Earth and it is created over here, which is this distance is 10 to 15 kilometer, and it is produced due to the cosmic ray collision with the air molecules. So the cosmic rays collide with the air molecule and form the muon. Its lifetime is 2.2 10 raised to the power minus 6 second. This is the muon average life. After this it decay. Muon disappear after this time. So how much distance it will travel in this time? It's falling toward the Earth because it is heavier than electron. It is heavier than electron, that is why it falling down to the Earth with a speed approximately the speed of light. Let's say with this speed, this is falling toward the Earth with this speed. Okay, classically it will cover the distance is equal to, with this speed you see 0.998 c, but c is 310 power 8 meter per second, and t naught is 2.210 minus 6. So this calculation gave us that it fall down this much meter toward the Earth. So it will never reach, if it cover this much distance, it will never reach the surface of the Earth because it is at least 10 kilometer above the Earth's surface. So this is 667 meter distance. It will decay over here, somewhere over here, and never reach to the surface of the Earth with this classical calculation. But this is not the actual picture. Time dilate, the muon speed is very close to the speed of the lights. Due to this speed, the time dilate for the muon. So let's calculate the time dilation for that. At t naught 1 minus v square over c square under root, and so we have to use this time, not the time this is, we see this time, we feel this time for the mu1, but actually mu1 lifetime is much larger than that, and this will be the mu1 time. So let's calculate it. Is t naught over 1 minus 0.998, cc will cancel, so this square, and it give us the time to be 15.8 time t naught. So this is the time, dilated time. So when we plug in this time instead of that one, how much distance the mu1 cover? In fact, that is vt this time. So that is v is 0.998 c. This is c meter per second, and time is now this one. This is 15.8, t naught is 2.2, 10 power minus 6 seconds. So this second will cancel with this one, and we will get a distance. So multiplying all these numbers, we have 10,422 meters, which is about 10.4 kilometer, which is in this range. So mu1 covered this much distance in its lifetime, but we feel very small time for it. The time dilated for the mu1, and that is why we observe many mu1 on the surface of the earth. On classical ground, it will never reach to the ground, because it classically it cover about 600 meter and then disappear classically. So it will never ever reach to the surface of the earth. But we observe daily many mu1 on the surface of the earth. So how it will reach the surface of the earth? Because the time dilate for it. The time is this. This is the time for the mu1, and in this time it cover this much distance, 10,422 meters, which is in this range. So that is why it reached the surface of the earth, and we experimentally we see them near the surface of the earth, and the reason is the time dilation for the mu1. Okay, so that is an example, and it is an experimental verification for the time dilation. Actual time for the mu1 is this, but time dilate due to the high speed of the mu1, and that is why it reached the surface of the earth. Classically it will never ever reach to the surface of the earth, but because it is very much less than 1 kilometer, while it has to cover at least 10 kilometer to reach the surface of the earth. So the time dilate for the mu1, and that is why it cover distant in this range and reach the surface of the earth. So that is an experimental evidence for the time dilation of the time dilation for object which moves with the velocity v comparable to the velocity of light. Its application, there are many application in GPS system. When a body moves with velocity v, and when a body is at rest, they feel different time. So GPS system work on the time dilation principle. Particle accelerator, space travel, and astrophysics, all these field works on the time dilation principle. When a body moves with velocity comparable to the velocity of light, will feel larger time, mean time dilate for them. And these system, all of them related with the particles motion with velocity comparable to the velocity of light. Time dilation is one of the most important prediction of special relativity. It changes the classical understanding of time. That time is constant for all observer. It is not constant for all observer. The observer moving with velocity v, which is comparable with the velocity of light, feel different time than the object moving with slow velocity. So time is not constant, and time is relative. Different observer feel different time. Different observer measure different time. The clocks of different observers move with different speed. The duration of second for a different observer is different. That is the conclusion. Like, comments, and subscribe. Thank you.